In today's lecture, we are diving into Unit 2 Matter to master the 6 ways matter change its form. We're going to decode the secret engine of phase transitions, which is the kinetic particle theory, and understand why temperature stays constant while molecules are shapeshifting. Whether it's the boiling point of a liquid or the mysterious jump of sublimation, we're covering every detail you need for your FBISE exams. If you put a thermometer in a pot of melting ice, you'll notice something that feels impossible. As the ice melts, you're adding heat, but the temperature doesn't move a single degree. It stays stuck at zero until the very last bit of ice is gone. Where is that heat going if it's not making the water hotter? Before we look at the changes, you need to understand the golden rule of matter, which is internal energy. This is a two-part system. Firstly, we have kinetic energy, and this is related to the temperature, while potential energy is related to the position and interaction of particles. But here is where it gets interesting. During a phase transition, the temperature and hence kinetic energy stays exactly the same. Instead, all that heat energy goes into changing the potential energy to overcome the forces holding the particles together. Most students get this wrong in exams. Temperature must always rise. You should always remember that the change of state is equal to constant temperature. Let's look at the upward transitions. Melting solid to liquid. In a solid, particles are tightly packed and only vibrate in fixed positions. When you add heat, they vibrate more strongly until they have enough potential energy to overcome the forces holding them in place. Then we have boiling, liquid to gas. Now the particles move faster and eventually gain enough energy to break free from the liquid surface into the gas phase. FBIC often asks about the boiling point. Remember, this is the specific temperature where the internal energy shift allows the liquid to turn into gas while the temperature remains constant. What happens when we reverse the process? Freezing from liquid to solid. As a liquid loses energy, the particle motion slows down and attractive forces pull them into a fixed orderly arrangement. For condensation, gas to liquid, the gas particles which were moving rapidly and were far apart, they will now lose energy and pull closer together to form a liquid. In both these processes, energy is actually released into the surroundings to allow these bonds to form. This release is why the temperature doesn't drop while the matter is changing its state. Finally, now we'll move to sublimation and deposition. Sublimation is when a solid turns directly into a gas without becoming a liquid first. Think of it like dry ice. Dry ice is basically CO2 in solid form. The particles gain energy to break free directly into the gas phase. And now for deposition, it's the opposite of sublimation. A gas now turns directly into a solid. This happens when the gas particles lose energy so rapidly that the attractive forces pull them straight into a solid arrangement without any liquid middle ground. Now you try this. If you are at the exact moment where water is turning into ice, is the temperature of that mixture 0 degrees or is it dropping below zero? Think about the constant temperature rule we just discussed. Drop your answer in the comments. I want to see who's learned the kinetic particle theory carefully. You've just learned the 6 transformations of matter. From the vibrating particles of a solid to the high energy freedom of a gas, you now understand the physics of phase change. If this step by step breakdown helped you clear your concepts, hit that like button and subscribe to our channel. We're making tough topics simple so you can score higher in your FBIC exams. Keep studying, stay curious, and I'll see you in the next lesson.